Hello and welcome to my channel. So in today's lab, we'll be configuring router on a stick as a step-by-step guide for network administrators. First off, let's quickly discuss what router on a stick is and why is it important to configure router on a stick in an enterprise network. So router on a stick is a term used in networking to describe a setup where one router is used to manage and route traffic for multiple VLANs using just one physical interface. One would ask, why do we configure route on a stick? So we configure route on a stick because it provides us with the most cost-effective and efficient and scalable method for routing traffic between VLANs, as opposed to purchasing additional hardware to allow for multiple physical interfaces on the router for each VLAN. Let's take a look at the task outline. So first, we will start by configuring static IP addresses on all end devices according to the IP subnets indicated in this topology. So we would begin by assigning an IP of 10.0.0.2, 255.192.0.0 because it is /10, and a default gateway of 10.0.0.1. Okay, so I would repeat the same steps for all the end devices across the floor. So 10.64.0.2, 255.192.0.0, 10.64.0.1. Ten dot 64.0.3, 255.192.0.0, ten dot 128.0.2, 255.192.0.0, 10.128.0.1. So now that we've configured static IP addressing across all end devices, the next step would be to configure the layer 2 switches. In the layer 2 switches, we'll configure the host names, but first let's use enable, configure terminal, then we'll configure host names. And VLAN to name, customer care, we'll exit, then we'll assign the switch ports to VLANs. Interface range else 0/122 switch port mode access switch port access VLAN. So we exit, then we'll verify our configuration using the show command to show VLAN brief. Okay, we've done this. Let's configure the floor 2 switch also using the same configurations. Enable, configure terminal, host name, floor 2 switch, VLAN 5 name, operations, exit. Interface, now we'll configure the switch ports to VLAN. Interface range 0/122 switch port mode access switch port access VLAN 5 exit. Also use the show command to verify our configuration. Show VLAN brief. Okay, and the floor 3 switch also using the same configurations. Enable, configure terminal, host name, floor 3 switch, VLAN 3 name, management, exit. Then we'll assign the switch port to VLAN 3 using interface range path internet 0/122 switch port mode access switch port access VLAN 3 exit. Using the show command to verify our configurations. To show VLAN brief. Okay, exit. Now that we've configured host names, we've configured VLANs and assigned ports to VLANs, the next thing we will do would be to configure dynamic trunking protocol, short DTP. So first, why do we configure DTP, or what is DTP?
DTP, Dynamic Trunking Protocol, is a Cisco proprietary protocol used to negotiate trunking on a link between two or more Cisco devices. So in this case, we will configure DTP because we want these switches to negotiate trunking automatically, saving me the stress of having to manually configure the trunking on the switch port interfaces.
So having explained what DTP is, let's go ahead and configure DTP on the floor 2 switch. Using the interface range command, interface, because I've identified its ports to be F0, 2, and 3. So range path Ethernet 0/324 switch port mode dynamic describe. Yes, you can see both interfaces are partaking in trunking at this point. Then we also configure for this interface G0/1 exit interface G0/1 switch port mode access, switchport access, switchport mode trunk. Then, having done this, we can now exit this interface. Now, the next thing I have after configuring DTP would be to configure VTP, which is VLAN Trunking Protocol. So one would ask, what is VTP? What is VLAN Trunking Protocol, and why do we need VLAN Trunking Protocol?
We use VTP to manage VLAN configurations across multiple switches because VTP allows us to create and manage VLAN centrally from a single server called a VTP server. So with VTP, I do not have to manually configure VLAN information on each switch because such information would be replicated across all other switches from the VTP server.
So now that we have understood what VTP is, so we would configure VTP on all the switches. Bearing in mind that the switch by default is a VTP server. So we'll configure the layer 2 switches to be VTP clients so that they can receive configurations from the VTP server. So on this switch, I will configure VTP mode client, VTP domain, network with Louis, .inc. Then I'll copy this. So I would copy this. Then VTP version 2, VTP password 1234, exit. So likewise, I will repeat the same configuration step for the float 2 and the float 3 switch respectively. Exit, VTP mode, client, VTP version 2, VTP domain, VTP password 1234, exit. Then for this also, configuration terminal, VTP mode, client, VTP domain, VTP version 2, VTP password 1234, exit. So now we've done VTP on the layer 2 switches. We would configure the layer 3 switch now. So on the layer 3 switch, we'll configure hostname, enable, configure terminal, hostname, Cisco 9300L. Then we'll configure VLANs, VLAN. So we'll replicate all the VLANs. So we'll configure VLANs, VLAN for this end devices. So VLAN 4, name, server room, exit. Okay, so I'll assign those switchport to the VLAN. Interface range, fast Ethernet 0/324. Oh, 2 to 3 rather. 2 to 3. Switchport mode access. Switchport access. VLAN 4. Exit. So we'll replicate all the VLANs that we've configured on layer 2 onto this layer 3. Then we'll use VTP to propagate them across. So VLAN 2, name, customer care, exit. VLAN 5, name, operations, exit. VLAN 3 main management exit. So use the show command to verify our configuration so far. Do show VLAN brief. So we see we have 4 VLANs. Okay. So having configured VLANs, the next will be to configure switch virtual interfaces or SVI. So now what is SVI and why do we need SVI in this network configuration?
We configure SVI because we want to allow a router to perform inter-VLAN routing, which is necessary for communication between devices on different VLANs. Because without SVIs, devices on separate VLANs would be unable to communicate or ping with each other. So SVI acts as a logical layer 3 interface for a VLAN on the switch, which allows us to assign IP address on an interface, making it possible for the VLAN to partake in routing.
So now that we've described what SVI is, we'll go straight into configuring SVI. So to configure SVI on the switch, I'll move into the virtual interfaces of those VLANs using interface VLAN 2. See, it changed state to up IP address. Or we assign an IP from this range. Then .0.0.1 255.192.0.0 exit interface VLAN 5. It also changed state to up IP address 10.64.0.1 255.192.0.0 exit interface VLAN 3 change state to up IP address 10.128.0.1 255.192.0.0 interface VLAN 4 change state to up IP address 10.192.0.1 255.192.0.0 exit. So let's configure DTP on this switch. First, we need to identify the interface of the switch. So this is gigabit 0/2. So interface gigabit 0/2 switchports mode trunk. You can see it gave us an error prompt stating that it's wrong. So to rectify this, we'll do switchports mode access switchports mode trunk. You can see shift it up, and also we'll do switchport trunk encapsulation.1q. We exit. On this interface, we'll also configure trunk interface gigabit 0/1 switchport mode trunk. It also gave us that error prompt, so we'll do switchport mode access switchport mode trunk. Okay, so now that we've done DTP on this switch, the next we need to do is to use VTP, which is the VLAN Trunking Protocol, to replicate our VLANs which we've created on this switch across all the layer switches. But before that, let's view our VLAN database using the show command to show VLAN brief. We'll see we have 4 VLANs in this switch, and if we try to view the VLAN databases of this you see we have just one VLAN. Show VLAN brief. You see, so show VLAN brief. You see, the VLANs have been replicated across. Show VLAN brief. And you see, all the VLANs have been replicated. Even the VLAN 4, which we created here, has also been replicated across all the layer 2 switches. So finally, we'll configure the router. So we can start doing the route on the stick. So configure the database of the router, enable, configuration, terminal, hostname, R0, then interface gigabit 0/0, no objects. Then we'll configure sub interface on this gigabit 0/0 interface. Gigabit 0/0.2. See, the database change state up, then encapsulation.1q VLAN 2, then IP address from this subnet 10.0.0.1 to 55.192.0.0. Exit. We'll repeat that for all VLANs. So interface gigabit 0/0.5. See the lines change state to up also. Encapsulation.1q VLAN ID 5. IP address from this IP subnet 10.64.0.1 to 55.192.0.0. Exit. Then for the other one, we'll do interface gigabit 0/0.3. See the line change state to okay. Encapsulation.1q VLAN ID 3 IP address from this IP block 10.128.0.1 to 55.192.0.0. Exit. And finally for the server interface gigabit 0/0.4. So I change this up. Encapsulation.1q VLAN ID 4 IP address from this IP subnet 10.192.0.1 to 55.192.0.0. Then we exit. So now basically we've configured rack on a stick. So let's test our connectivity. By pinging from this laptop. But before that, let me confirm my IP address using the command ipconfig. And this is my default gateway. So I can ping my default gateway using ping 000.1. And you could say I can ping successfully. Then let me ping this device 10.6402. Ping 10.64.0.2. Okay, I can ping successfully. Let me also ping this device 10.64.0.3 and 10.64.0.3. See, I can ping this device also. Let me see if I can ping my printer 10.128.0.2. Ping 10.128.0.2, and I can ping successfully from all devices. And lastly, let me ping from my PC 10.192.0.3, 10.192.0.3, 10.192.0.3. Okay, so you see everything is working all right. So that brings us to the end of our configuration tonight. So stay tuned, guys, and thanks for watching.